Welcome, everyone. Today, we are exploring a crucial architectural decision in modern AI workflows, understanding when to design custom GPTs versus when to utilize Claude's projects feature. Let's get started. Let's start by defining AI workspaces. When we talk about AI workspaces, we are looking at dedicated environments where a foundational model is customized with specific instructions, documents, and tools. The two heavyweights in this arena are OpenAI's custom GPTs and Anthropic's Claude projects. Why do we need them? Because constantly pasting the same background information into a blank chat window is incredibly inefficient. By using a workspace, we establish a persistent baseline. However, how these platforms handle your data and manage conversation history differs fundamentally. Our deep dive today will reveal whether your specific workflow requires a single-purpose agent or a persistent, collaborative environment. Looking at this flowchart, you can see the split from standard AI chat. Standard chat inevitably leads to repetitive prompting. By moving into AI workspaces, we diverge into two primary methodologies, custom GPTs, which are heavily focused on specific tools and external actions, and Claude projects, which are optimized for deep context and persistent document management. We will explore each path in detail. Let's examine custom GPTs. A custom GPT is a specialized assistant created within ChatGPT. You build them using the GPT builder, defining a specific persona, a strict set of rules, and uploading reference files. Why build a custom GPT? They are phenomenal for creating highly focused, single-purpose tools. For instance, you could build a data scout to analyze CSVs or a tool that connects directly to your company's database. This is achieved through custom actions, where you provide an open API specification, allowing the GPT to make live HTTP requests to external services. It essentially transforms the chat interface into a natural language front-end for your APIs. This architecture diagram illustrates the mechanics of a custom GPT. A user request enters the GPT and is immediately filtered through the defined system instructions and uploaded knowledge. Crucially, if the task requires it, the GPT can trigger custom actions, reaching out to an external database or API before synthesizing its targeted response. It operates as a highly specialized, self-contained worker. Now, let's pivot to Claude projects. If a custom GPT is a specialized tool, a Claude project is a dedicated virtual office. It allows you to organize related conversations and store shared background documents for reference across multiple sessions. Why use a project? It is the ultimate environment for long-term, evolving tasks. If you are writing a novel, you can upload character sheets and style guidelines to the project's knowledge base. Every new chat you start inside that project instantly has access to those reference documents. Unlike GPTs, which often reach out to the live web via APIs, Claude projects are optimized for deep, secure synthesis of your internal data, leveraging Claude's massive context window to analyze dense, complex materials. This diagram maps out the Claude project workspace. At the top, we have the shared project knowledge, which holds your static reference files like codebases and style guidelines. Below, you see multiple independent conversation threads. The dotted lines indicate that the shared knowledge automatically feeds into every new conversation thread you create, providing a consistent baseline of information without needing to re-upload files. Here we uncover the most critical difference: context management. A major pitfall for new users is assuming that a Claude project automatically remembers every conversation you've ever had inside it. It does not. Projects organize conversations, but they do not automatically maintain context between them. Why? Because dumping dozens of past chats into a new one would instantly fill the context window, causing the model to lose focus. Therefore, Claude requires manual context management. As an expert, you must start new conversations by explicitly setting the stage, for example saying, "Based on our previous conversations saved in this project, we've decided on X." You must actively curate the memory to keep the AI focused and efficient. This state diagram illustrates the manual context management loop in Claude projects. We have chat thread 1 where active work occurs. To transfer knowledge to chat thread 2, the user must save a summary of chat 1 into the shared knowledge base, often as an artifact. Then, when starting chat thread 2, the user manually references that saved artifact. It is a deliberate, human-driven transfer of context. Next, let's compare how these workspaces output their results. Custom GPTs are highly transactional. They are built to generate text or trigger an external API action, like updating a database. Claude projects, however, introduce a revolutionary feature called artifacts. An artifact is a persistent, editable document that lives in a panel right next to your chat. Why is this so powerful? It solves the scrolling problem. In standard AI chats, if you ask for a revision, the AI reprints the entire document at the bottom of the chat. With artifacts, you can simply ask Claude to update the second paragraph, and it updates the living document in real time while you converse. It is a true collaborative workspace rather than a simple command and response terminal. Observe the sequence diagram demonstrating the artifact workflow. The user requests a script in the chat, which prompts Claude to generate a living document in the artifact panel. When the user requests a targeted update to the error handling, Claude modifies just that specific section of the artifact. The document evolves steadily in its own panel, completely independent of the scrolling chat history. Let's bring this to life with a real-world use case. Imagine you are the CTO of a SaaS company. You have two ongoing initiatives, analyzing weekly user telemetry CSVs and executing a massive, multi-week rewrite of your core software architecture. Attempting to do both in a standard chat would be disastrous. Instead, we use the right tool for the job. For the weekly telemetry, you build a Data Scout custom GPT equipped with code interpreter. It is transactional: upload the CSV, get the charts, and move on. However, for the V2 architecture rewrite, you create a Claude project. You upload your current API docs and design guidelines into the project's knowledge base. This guarantees that your transactional data tasks do not pollute the delicate, evolving context required for your complex software engineering effort. This decision tree routes our CTO's requirements perfectly. Task types that are transactional, requiring specific code execution on files, are routed to the custom GPT Data Scout. Tasks that are persistent and evolving are routed to the Claude project for V2 architecture. The GPT yields fast, isolated outputs, while the project facilitates long-term, collaborative design through artifacts. Let's look at the tactical execution. For the custom GPT, we write explicit system instructions. You are a data scout. When a CSV is uploaded, use Python pandas to identify outliers and return a structured JSON summary. It is an automated pipeline. For the Claude project, we execute the serial project approach. We don't put everything in one chat. We create one chat for database schema and a separate one for the auth flow. As the auth flow chat wraps up, we instruct Claude to summarize all our architectural decisions into a security artifact. Then, when we start the third chat for the front end, we explicitly reference that security artifact. This manual context transfer ensures the front-end chat understands the security constraints without having to process the thousands of tokens of debate that occurred in the auth flow chat. Here we see the lifecycle of knowledge within a Claude project. The auth chat develops the security constraints and explicitly saves them to the project knowledge as an artifact. Later, the front-end chat begins. The user manually prompts the chat to reference that specific artifact. The precise constraints are loaded, allowing the new chat to develop a compliant UI efficiently without unnecessary token bloat. To wrap up, your choice between these platforms dictates your success. Use custom GPTs when you need shareable, highly automated tools that connect to external APIs and perform repeatable tasks. Use Claude projects for your deep work synthesizing complex documents, coding architectures, or writing books using persistent artifacts. Above all, avoid the automatic context expectation pitfall. Remember that projects organize your work, but they do not automatically carry conversational memory from thread to thread. You must manage that context manually. Master these environments, and you will multiply your productivity exponentially. Thank you for joining this masterclass. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final mind map summarizes your workspace strategy. AI workspaces branch into custom GPTs, characterized by external APIs, single-purpose tasks, and shareability. On the other side, Claude projects are defined by deep focus, living artifacts, shared static knowledge, and the crucial requirement of manual context management. Choose the right tool and elevate your AI engineering.